Auzu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. Scales. In our today's lecture, we are going to study about different scales used in engineering drawing. So, the scale could also be used for reducing the size of an object, which could be quite larger as compared to the space available on your drawing sheet. So, to make it convenient to be drawn over your drawing areas, the objects to be drawn must be drawn smaller to their actual sizes or smaller than their actual sizes, or they may be drawn larger than their actual sizes if their sizes are very small. So there could be reducing scales for objects drawn smaller than their actual size. For example, if you want to draw a line, for example, 100 meter long, so that cannot be drawn over your drawing sheet area because your drawing sheet area will be lesser than zero point 0.5 meter. So you would have to reduce the size as compared to its actual size in order to be conveniently drawn over the available drawing area. Or you can use enlarging scales for objects drawn larger than their actual size. So oftenly we will be drawing objects very smaller as compared to our drawing area. For example, the object can be in micrometer or nanometer, so that cannot be even visible if you draw it to their actual sizes. So they must be drawn larger than their actual sizes in order to be visible, as well as in order to be drawn conveniently with your drawing instrument. For example, you cannot draw a very smaller circle. You will have to magnify that in order to be drawn with the compass. Now, whether you use whether you use a reducing scale or an enlarging scale, that must be represented on your drawing sheet so that the reader could understand the actual size of the object. A representative fraction. So for that, representative fraction is used. It is the ratio of the length of the drawing to the actual length of the object represented. And the representative fraction is represented in this form x ratio y, where x is the unit on the drawing, whereas y is the representation on the actual object. For example, 1 ratio 2 would mean that an object of 2 units has been drawn as 1 unit, or you can say that an object of 2 inches has been drawn as 1 inch. So this is a reducing scale, and you can see that it is half scale because the object of 2 units has been reduced to 1 unit. So it is a half scale and is a reducing scale. You can also enlarge a smaller object through this representation. 2 ratio 1 means that an object of 1 unit has been drawn as 2 units. The units could be any measuring units, for example, inches, meter, centimeter, etc. etc. So this is an enlarging scale. And you can see that it is a double scale. An object of 1 unit has been enlarged to twice its size or has been doubled. So this is an enlarging scale or double scale. So this must be represented on your drawing sheet. In metric system, these representative fractions could be in this form 1 ratio 2, 1 ratio 2.5, and so on up to 1 ratio 250. You can go beyond this 1 ratio 500, 1 ratio 1000, 1 ratio 10,000, etc., etc., depending upon the size of the object and the available drawing area. If the object is very much larger as compared to your drawing area, so this fraction will also be larger. 1000 ratio 1, 10,000 ratio 1, like this. For enlarging scale, you can have these fractions and you can go beyond this if the object is very smaller. For example, you can go up to any limit depending upon the actual size of the object and the available space of your drawing sheet. Now, in English system, the representative fraction can be in this form 1 ratio 2, 1 ratio 3, and so on, and vice versa for the enlarging scale. Now, you can you can make your own cardboard scale and can make any number of fractions for 1 unit. For example, if you want to divide an inch into 8 equal divisions, or in other words, if you divide an 8 into, if you divide 1 inch into 8 equal parts, then each part will be 1 by 8th of an inch. So for that, you will have to draw a line of 1 inch from here to here. You can see this that this line segment has two endpoints, this one and this one. So first of all, divide it into two equal halves through perpendicular bisectors. Open your compass to any convenient length and this end as a center. Draw two arcs, one above the line and one below the line. This as a center. Now, keeping same opening of the compass, now this be the center. Draw another two arcs, cutting the already drawn arcs at this point. Now join the intersection point. Now this is not a very straight line because I am drawing it free handedly. You will be drawing it with the help of the compass and a ruler. So you will divide it into two equal half. So you have divided the 1 inch into two equal parts, or 1 by 2. Now you got these two line segments from this point to this point and from this to this. Now again divide it into two equal halves. So this be the center. Draw two arcs and this be the center. Draw two arcs in order to divide this line segment into two equal parts. Similarly, do it for this line segment. Now you have divided the line into four equal divisions. So each division is 1 by 4 of an inch. From here to here, 1 by 4. Now you can divide these line segments again into two halves through perpendicular bisector. Now you have divided the 1 inch line into 8 equal parts and each part is 1 by 8 of an inch. You can go further and divide this line segment as well as these all line segment into equal halves. So you will finish it with 1 by 16. You can go beyond this as well. Divide again this line segment from here to here into two equal part and go on and on dividing all the other line segments. You will finish with 1 by 32. You can go beyond this 1 by 64 and so on. So you can see that you can go up to any fraction through your own cardboard scale or the scale drawn with a harder, uh, for example, sheet, in this case, a cardboard. But you can see that as you increase the number of divisions, so the space between the division decreases and you will finish with overlapping these divisions. So you will not be able to differentiate between the division. So further fraction 1 by 64 or beyond that would not be possible. You can similarly divide a decimal. For example, in decimal system, you will be dealing with a fraction of 10, 1 by 10, 2 by 10. So each time, for example, if you draw a line of 1 centimeter and you want to divide it into 10 equal division or 1 millimeter, so for that, first of all, draw a line of 1 centimeter. In this case, first you draw a line of 1 centimeter and then divide it into two equal halves through perpendicular bisections. Bisection, sorry, as I have already told you. Now, further division would not be possible with the help of perpendicular bisector because each of this line segment now from here to here will further be divided into five divisions, not four. Four is possible through perpendicular bisection, but five equal division of a line segment will not be possible with perpendicular bisection. So, because you can see from here, if you start one division, two, three, four, five. So, these five divisions cannot be drawn with perpendicular bisection. With perpendicular bisection, you can divide it into even number of divisions. So for this, you will use hit and trial method. Now, what is hit and trial method? This be the center, open the compass to a convenient length so that you understand that you want to divide it into five equal divisions. For example, you have opened your compass to this much length. Now, first division, second division, for example, third division, fourth division, and the fifth division is lacking behind this division. So, you have not accurately opened the compass. So, for the next try, open your compass a little bit more. For example, a little bit greater than the previous opening. So, for example, then you can have this as a first division, this as a second, this as a third, this is a fourth, and this is a five. So, if you end exactly at this division, your fifth division, ends exactly at this uh, bisection or division. So you are done with. You have done the job. But for example, if the fifth division is surpassing this division, so it means you have opened the compass a little bit more. So for the next trial, close the compass so that you end up exactly at this division and the fifth division exactly ended at this point. So this is how the hit and trial method is carried out. That is why it is called hit and trial. It can be hit it in the first go, or it would require two or three chances or turns, or for example, the goes to achieve your exact divisioning. So that is why it is called hit and trial. Now, as we have seen that in our previous, for example, this method of uh, dividing a unit into number of fractions was, for example, ended due to the overlapping. If we increase the fraction up to 1 by 64, so these division could overlap, so we cannot go beyond that. Now, the remedy is by using diagonal scale. You can go up to any fraction of an inch or of a decimal system with diagonal scale. For example, here we are going for 1/100 of an inch. So you can measure 1 by 100 of an inch. Or in other words, the inch would be divided into 100 equal parts, and each part would be 1 by 100 of an inch. So for that, draw a line of 1 inch. Draw a horizontal line of 1 inch and erect two perpendicular lines, this one and this one, from the two ends of this horizontal line. Now complete the figure. The figure could be square because you will have to draw this line exactly of 1 inch. You can draw this vertical line of 1 inch or greater or smaller than 1 inch. That depends on you, because that will not make any difference as far as you have drawn this horizontal line of exactly of 1 inch. So complete the figure. Now divide this horizontal line into 10 equal divisions with hit and trial method, because 8 equal division can be done with perpendicular bisection method, but 10 division cannot be done with perpendicular bisection. So for that, you will have to use hit and trial method. So divide this line into 10 equal division, the upper half as well. Now also divide this vertical line into 10 equal divisions. Now draw lines, slanted lines, joining one of the top face to the zero of the bottom face. Now repeat the process till joining the 10th division of the upper face to the 9th division of the lower face. Also draw horizontal lines from these divisions, crossing these slanted lines and ending at this vertical line. Now you have actually divided this figure into 100 equal parts. Now, each of these divisions, starting from this is 1 by 100, this is 2 by 100, this division is 3 by 100, this is 4 by 100, this is 5 by 100, this is 6 by 100, 7 by 100, 8 by 100, 9 by 100, and 10 by 100 are 1 or 10. Each division is 1 or 10 of an inch. This each division from 0 to 1, from 1 to 2 is 1 by 10 of an inch. And this 1 by 10 of an inch has further been divided into 10 equal parts, each one. So a total of 1 by 100 divisions. So a total of 1 by 100 division. Now you can take a reading of 0.37 of an inch. So as I have told you, this one division is 1 by 10, 2 by 10, and 3 by 10 are zero point 0.3. So this is zero point 0.3, and going on this line towards the top. So you are increasing the measurement beyond the 3. So this is zero point 0.3, this is zero point 0.31, 0.32, 0.33, 0.34, 0.35, 0.36, and 0.37. So you can come along this line up to zero point 0.3, and where the seventh division intersects this line of 3 joining the 4 will be the zero point 0.37. This is zero point 4, and this is 0.39, 0.38, and 0.37. Now from here to here it is 0.37. Now you have measured 0.37 from here to here. Now you cannot take this measurement with these two faces. For example, this upper face, you can exactly measure from 0 to 4, but that would be wrong because the actual is 0.37. You can, for example, approximately uh, measure it. For example, if you come to this position, so that would be approximate. And also, you cannot measure 0.37 exactly with this edge as well. You can measure zero point 0.3 with it or zero point 0.4 with it, but you cannot measure 0.37. So this measurement should be taken with the help of the compass, and keeping the opening of the compass the same, you can place this, for example, this measurement over the line or over the area. So that would measure 0.37. Now, for example, if there are whole inches with that, so the diagonal scale will be like this. Only one division will be divided into fractions. The other would measure the whole inch from 0 to 1, 1 inch, from 1, 2 inch, and 3 inch. So, for example, if you are given 1.37, so you knew that from here to here that was 0.37, and join 1 inch with that, so that would become 1.37. Now you cannot take this dimension exactly with this diagonal scale because either you will be taking this distance or this distance exactly with these two faces, but you cannot get this length exactly with these faces. So you will have to take this measurement with the help of the compass. Open your compass from here to here and take this reading where you want to draw a line or something of this measurement. 2.64, point 1, point 2, point 3, point 4, point 5, point 6, point 61, point 62, point 63, point 64. So from here to here it is 0.64. Now add 2 whole inches with that. So that would make 2.6. This division, this measurement, sorry, cannot be taken with the help of these edges exactly. So you will have to take this measurement with the compass and will place it anywhere you want to draw a line of this measurement. Fraction based diagonal scales to measure dimension with the least count of 1 by 64 of an inch. We have already seen 1 by 100 of an inch. Now to measure 1 by 64 of an inch. So the same procedure, draw a line of 1 inch, erect two perpendicular lines from the two ends. This perpendicular line may be of 1 inch or may not be of 1 inch. That would not make any difference. And complete the or close the figure. Now divide this lower horizontal line into 8 equal parts. That can be exactly done with the help of the compass through perpendicular bisection method. Also, the vertical line into 8 equal divisions. Now join the one with the one of the upper half or the upper face or the upper edge with the zero of the lower edge or face and draw slanted line like this. Also draw horizontal line from each division of these vertical divisions. Now actually this one division from 0 to 1 is 1 by 8 of an inch. That has further been divided into 8 equal parts. So if you start from here, so this one is 1 by 64 of an inch. This is 2 by 64, 3 by 64, 4 by 64, 5 by 64, 6 by 64, 7 by 64, and 8 by 64 are 1 by 8. Similarly, after that, so for example, this one division. So after 1, 1 by 8. So for example, this one is, this was 8 by 8, 8 by 64, 9 by 64, 10 by 64, 11 by 64, and so on. Now you have divided this into 64 equal divisions, and you can go along and measure these divisions. Now, if you want to measure 45 by 64, so as I have told you, this one division is 1 by 8, 2 by 8, sorry, 1 by 8, 2 by 8, 3 by 8, oh, sorry, one is 1 by 8 and this will be 2 by 16 in order to be 1 by 8, 3 by 24, 4 by 32, so on. So, for example, this one is showing 8 equal divisions, as I have told you. Up to this, 1 by 8 has been further divided into 8. So, this one division is 1 by 8, again 1 by 8, 1 by 8, 2 by 16, 3 by 24, and 4 by 32, 5 by 40. So, this is actually 40th division: 41, 42, 43, 44, 45. So, this is 45th division of the total 64 divisions. So, this is how to measure fractions with the diagonal scale, and the whole inches can also be the part of the diagonal scale. One whole 45 by 64. So from here to here, it is 45 by 64. You can measure it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, and 45. So this is how. But the easiest way is to come up to the 40th division. We should be in the 5th division because each division is further divided into 8 equal parts. So 5 would be the 40th division. So from this onward, you can go up to 45. To hold 27 by 64. 27 as the third division is 24, 25, 26, 27. So from here to here, 27 by 64 and add the whole 2 with it. So from here to here, a total of 2 whole 27 by 64, and you can take this measurement with the help of the compass. 1 by 128 of an inch. So for that, draw a line of 1 inch and divide it into 8 equal divisions and divide this perpendicular line into 16 equal parts in order to totally get the 128 division. You have first divided this horizontal line into 8 equal parts, make it 1 by 8 of an inch, this one division, and further divided this division into 16 equal parts. So 8 into 16 makes 128. So for example, starting from here, this division from here to here is 1 by 128. This is 2 by 128, 3 by 128, 4 by 128, 5 by 128, 6 by 128, 7, 8, 9, 10, so on up to 16 by 128. Now, this one division is 16 by 128. And from this, sorry, 17 by 128, 18 by 128, 19 by 128, and so on. So you can see that each division is 1 by 16 or 16 by 128. Each division is, so this, so the two division would be 32 by 128, 48 by 128, 64 by 128, 80 by 128. So if you want to measure 83 by 128, so first you would come to the fifth division, which is the 80th division. So from this onward, 81, 82, and 83. You can also come from above. This is 96th division, 95, and come along this 94, 93, and so on up to 83. Now this measurement is equal to 83 by 128. You cannot measure this measurement exactly with these edges. So you can do it approximately, but you can, so for doing it exactly, you will have to take this measurement or this distance with the help of your compass and would take it to the place where you want to draw this dimension or measure this dimension. One whole 83 by 128. So from here to here, it was 83 by 128. Now add a whole inch with this. So from here to here, it is a total of one whole 83 by 128. I hope you have understood this lecture. I will not go further. Inshallah, the remaining part will be covered in the next lecture. So, thanks for today.